N1. So first you can refer the formula sheet. Then you can tell me the formulas for each. Okay, so maybe first with the spring. So all we say, when you say linear system, all we call as a F. Here is all the T. TK1, what is the formula? TB1, what is the formula? And TK1. Okay, so I can say net. You can say net day one. So what is the formula? Again, do you have a formula sheet? You don't have formula here. Maybe open. Yes, that's a formula. So we have these three components where we are going to write down. Okay, so that's a mass, spring, and damper. Let me go back to get it bigger. So first what I return is a spring. Spring formula is K. Okay, K1, right? Theta 1. Okay, next we have a damper. Damper is this one. Because it's theta, because what you can say theta 1 minus theta 0. Because this is the starting one, so no theta 2, that's why it becomes 0. You got a theta 1 actually. And the second one is omega 1 and 2. Okay, so that is based on the F. We call it here is a B. Okay, so B1, right? B1 is omega dot or maybe dot, yeah. Okay, then torque of the mass, this one, J double 1 double dot. So maybe first you write down this way, then you can remove the dot. Okay, so this one remains as it is. K1 theta 1, then B1 theta 1, B theta 1, one dot, right? Then this one J1 B square theta 1. So you will go by component. Then you can write. So I can name it equation 1, equation 2, equation 3. Okay. From that, how we can able to make it. So when you write, this is called as component equation or system equations. Then other one is force equation. So maybe you say components. So based on the question what they given, then force equation. Force equation. So we start from here. I apply torque 1 in all the component until to N1. So all the force you can say. So start from T1. So because torque 1 is the one I am applying manually, so that is equilibrium, right? What is the other component is opposite of this T1. Okay, so what do you have? All this thing. T K1, T B1, T dot net 1. What else? Is anything missed out? There's one N1. capital letter. So that is we can say as a force equation. One is component equation, the next is force equation. That's it. So that is for what we written for shaft 1. Okay, so shaft 1 is this entire thing. Then I talk about like shaft 2. Okay, based on the component you can write, then you can work on it. Questions? Anything? So we good? Or we have any questions you can raise now? So that's how you can able to build any question given. First refer your formula sheet, write down and make equation 1, 2, 3 kind of thing. Then force equation. So this part we completed. Then for completed start to shaft 2. This part you can write. That is you have J2, spring, N2. So 3 over there.
Next one.
So first I will try to practice the system equation with few exercise. Okay. Alright. Maybe I think that I write down over there. So. Okay, for this question, at least I can leave it. I don't know whether I can see here below. Cannot. Okay. Okay, shaft 2. So shaft 2 we have K2. Okay. Okay, so it's 2 equation only, 2 components. So it's K2, J2, right? What is this? 2. This one? Okay. You can write on the next step. I think it's still the same, even though you can write down so that you can refer. E square. So there's a 3. Okay, maybe I can say this is equation 4. Or maybe in the fourth equation you can maybe number it later. So I can say 3, this is 4, this is 5. So 5 component equation. Then we'll talk about like a fourth equation. What is the fourth equation on this? T2. T2. Okay. T. K2. J2 equal to
N2.
N2.
TN2.
Tn2. So that is, maybe I can number now. This is 6. This is going to be 7. Okay. So first we will look at the component and write down the component equation, then force equation. Then we are trying to combine to make it your final transfer function. That we'll do later. At least now first step, writing the component, writing the equation, force equation. Okay. What is the transfer function for this question? Yeah, that is your part 1. Output versus input, right?
Yep.
What is your output for this question? You can read the question. From here, 2 gears is 2 shaft, and number of gears K1, K2 with a spring, dampers, and driving torque T1, and rotational angle θ2 taken as an input and output. Okay, T1 is input, and θ2 is your output. So you need to read the question. From the question, which clearly specify which is your input, which is your output. Then you can basically now 7 equation you have to get this ratio. So you can do whatever you want to do it and try to get it. How to do it? Okay. Basically the force equation is a key part of it, because this is a component equation. the first equation, all these values substitute over here. Okay, so 1, 2, 3, 4. All you need to substitute onto the first equation. Okay, the formulas is from here. You get the value and substitute on here. That makes your first equation. And also here we have a seventh equation also. TK2, J2. Yes, we can substitute on here. Then you can make it. Then you combine these two force equations to get your transfer function. Okay. So at least I'll give an overview first. Then we'll do more exercise and you'll be get to it. So are we good? Or we have any question? Maybe just I put it in
你明白吗？你看到
Unless if you
TK1
want
的
to take a
佛的嘛
photo, you can take a
，TB1
photo.
也是有 T1 是 0，这是 T1。
I think this slide I will share anyway, you can refer on it. Who are not able to take, at least you can see here. Okay, yeah. This is the first one, the sharp one. We have three components, force equation. Okay, forget about this one, which is Laplace method to write. Okay, so the same thing. I need to put yes, yes, yes. Yep. So leave it this. Ignore this last line.
哦，对对对。
Then sharp 2 force equation, and this is the general equation for shaft rotating. The speed, so called number of teeth, and the speed and angle. That is the common formula for rotational shaft. Or you can refer, then you can able to write it out. So that is the answer. Okay, so don't worry about it.
你要缠那个缠哪个？
Right?
缠到很难的。
I mean this one. Angle.
About N1 to 8。
Angle. It is always opposite. The ratio changes. That's a formula. Of course, the formula, I mean the answer for your reference, you try and see whether you can able to get it. The answer is on the next page. That is your transfer function. Okay, who are done, you can proceed this one. I think we not done this one, but of course similarly first order we done. Start to write the equation. So at least I expect how many components? 1, 2, 3, 4. 4 equation must be there. Write the 4 equation, refer your formula sheet to write it. Then one force equation will be there. Okay. Component is 4. First you write down. And tell me what is your output, what is your input. Of course here, okay, already written. Over here. Because it's over here. F is your input and X2 is your output. That is the final thing what we are going to achieve. Okay, so take note this one. 6. Then we have this. Okay, just take note. Then we'll proceed to this. You can write the formulas. Usually when I have practice, like when I have the springs, I will write the spring first, then mass second, then all the damper, then I'll write the spring. Because at the end of the day, it is following TK1, TK2, or TM or TDAN, and TC. Okay, so we need to go any order, but at least you don't need to refer again and again the formulas. So we good?
还可以聊东西。 我跟你讲，看到这个讲话很大声的，你是晋级不地位呢，那你是要
Okay, the first one, maybe I first write down the component TK, sorry, FK1, right? because force. K2,
那个 assignment
yeah,
是
C,
也是很讲一点不讲一点，
F
有
net.
一个跟有的
Yeah, that's only one must. I can put M also can.
那个前面两个，
Okay, formula.
你按哪会给？啊？你按哪会给我？可以，你给我后尾吗？可是后尾好明白了。
K times with K1, K2, yes. K1 is here. X1, okay. K2 on there,
小
X2.
娃回来。
FC, C is like, C is a damper. X2 minus. Yeah, so because the force is applying. Sorry, which
为
one?
了这里卖。
K2. Where is the spring? Oh yeah,
他在买那个卖。
it is. Because now, very simple, when this spring is here, when I press it, it's only based on this because it's grounded. But here, this and this, two distance is there. So x2 minus x1. Yeah, correct. Then damper.
从变成10块。
Damper. Okay, so you can also write other ways. X2
要看它1年过后的。
dot. Okay, later we can change dot. Okay. Yeah, you can convert to D. What is the next mass?
这样，明天要做，一起做。
M
没看中。
one or two? One. Okay, so we have the equation, but better convert the equation. Yeah, this one no change. Anyway, write down K1 X1. And here also no change. This one. Instead of one dot, you can make it as D. X2 minus X1. This is a double dot. Okay, so oh yeah, missed out. Oh yeah, that's why it's a common mistake. You start to write itself can make mistake, so be alert always. And once you write, recheck actually. Okay, so when you do it, of course, write number the equation. So at least this is covers all the component equation. So we get it 1, 2, 3, 4. It doesn't matter which order you're writing. Then next is force equation. And applying the force F, this component is again on it. Okay, write the force equation. Force equal to all the components. Or maybe you can say where you apply. Okay, now when you apply this force, these two components against this one, right? So force equal to these two components, Fk2 plus Fc. That is your first force equation. So this is against of the applied force. Okay, this is trying to equilibrium. Okay, but what about this these forces against of this? Okay, that's the next one. Okay, so first, any question on the components? 4 components. We can refer the formula sheet to write all the things. Of course, based on the question, what is the component given, then we write it. And we need to follow, let's say x1 or x2, then we need to follow accordingly. Okay, first I would like to write one of the force equation, F. Yeah, correct. Based on for two components, you have spring and you have damper against opposite. So I can say F K2 plus C. Yeah, C. So that is my fifth equation. So it is nothing but your fourth equation. Then these two component is against of these two. Okay, so I can put in equilibrium. It's not like saying that it's trying to equilibrium. Okay, what do we have, like F K2, right, plus FC is equivalent to Fm plus K1. Okay, are we good? We have a question. Fk2 C A, which one? Overall force. Give it this one. Maybe not, because it is like a layer suppression. If this spring over here, yes, because directly it is reciprocate on it. Now this is like a one layer suspension, then another layer suspension. So if we talk about this spring, is not directly take from there, right? Is whatever cumulative is getting here, then it will be again from that. That is simply to say our train system. Train tracks, this is the tracks. Then above the track there is a leaf spring, that is where we are sitting on top spring. So our weight is over here, which is compensated partially over here, then again another partial over here. But no matter what is our train system, a lot of noise, lot of motion, still the suspension is not good enough. Okay, that's why you can see a lot of noise actually. But if we compare, the more worse strain, then we consider this is best already. Okay, so it's never going to be the same always. Okay, so understand about the 6 equations over here from our question. Any question on this? That's the first step. Yeah, rewriting, find all system equations. Okay, that's what we are trying to write actually. Okay. Writing the system equation doesn't take a lot of time. Maybe consider 10 minutes or 15 minutes, you might able to end up, and usually it's a 20 marks, 6 marks is based on this. Just write the equation, refer your formula sheet, writing the component based on that. That's it. So it's very simple, and when you attempt, don't leave it blank anything. So at least refer your formula sheet, then write it. Okay. Even one of the formula, one of the equation wrong, is okay. At least that only you won't get it. The rest you will get it actually. Okay. That's why I go like a very detailed, and I want to do more practice, because this is where if this is not able to make it, even I cannot jump into part B or part C, because part A, if you complete not only can go part B. Okay. So all is connected. Okay. So of course this one have a detailed step. Yeah, I have formula sheet over there. Yes, what we return, let me see. Oh yeah, so Fk, C, K2, then I return 1, 2, 3, 4. Then force of the spring, I mean the original applied force, then against the force. Then based on that you can rearrange to get x2 divided by f. Okay. So how to rearrange? Obviously we are trying to use equation 5 and 6, because 5 and 6, let's say K2, I know what is the formula for it, then I write off. Then C also same thing. All the 4 equations going to substitute here as well as here, then rearranging. Just giving a very detailed steps. So equation 6 in 1, 2, 3, 4. So you just substitute all the values over here, rearranging, then I try to make it one equation, which is 7. Then substitute onto the 5th equation, same thing, until I get to stuck somewhere. Then replace the x1 based on the value we did. Then substitute to get what is the ratio, which is coming over here, then rearranging. Even the slides is keep writing on it, but maybe it's like longer because the slide is very short. When you have A4 paper, then it's a bit easier to do it. Okay, so you can refer this one, and for this case like a more time constant, because okay, this is a higher order system. So usually we have 1D only, so far what we've seen. Now we have a d cube, d square, d and everything in the numerator as well as in
Yeah,
denominator,
that's-
then the formula for higher order is like this. The numerator start like t1, t2, t3, t4, t5 kind of thing. You can continue. Okay. So once you have that, then we can able to write all the time constant as well as the gain constant. Of course, I can leave it. You can just browse first, then see whether you can able to understand. If you have any question, you can post. Okay. Then yeah. So overall, 6 equation. Part B is rearranging the equation until to get as x2 divided by f. Then find the time constant as well as gain constant for the question. Okay, that is we classify as a higher order system. Let me put it. Restart. I want to make a system equation for this question, and as we see, this is your input and that's your output. Okay. Yeah, because I corrected the question. Supposed to be here, but it should be better here. Okay, right? And when you do it, you can number also. I put it like 1, 2, 3, 4, 5, 6. At least I won't miss out the components. Okay, write 6 equations first. Yeah, something like this, based on the component. So if you want to write, I can say write all the spring first, then all the mass, then damper. We have already 3 spring, right? Okay, yeah, 3 spring, 1 damper, 2 mass.
K1, K2, K3.
So write all the spring first.
K1,
K1, K2, K3,
K2
then damper, then mass.
K1, X1.
But you need to put it
写这个就有
x1, x2 或者几个。
K2 这两个，对吧？所以 example 做的话，你直接从先写这个传就有了。
So anybody want to take note this one? Oh, it's okay. Can I erase?
我觉得那时候你的发现，你的 FPA 是拿到高的。没有，对啊，我懂你的 FPA，你的那个是拿高的。你要两个。
You can refer the formula sheet. If you want to do it.
没有，我不是要离开什么，我要知道你的那个拿的资料。就是还有2个前面，还有2个model。除了 FPA 还有什么 model 啊？我忘记了。
Okay, so you need to write all the things, then put the respective formula. So all the 6 components on here.
43。
Then you can look on formula sheet, check one by one, then you can write.
所以43那个你只能score在哪一个？啊？对啊，你只能score，因为你家43，你还要全部做完那个啊？全部做到完。全部做到完。可是你做到你工作。可是你们摸到什么东西？那时候，整个模就这么多东西，你就没摸到什么东西。整个往上面有，59，另外是吧？他有写什么？他写
Okay, so hope guys return, so guide me. K1, K2, easier way to write because we know the first is constant.
你看
And
那个
just
K1
put directly.
你抄到。
B, Yeah.
and M1
X1
X1
or U1? No.
X1
X1. Oh yeah. X1. Yeah, correct. Okay, so basically it's very simple. Now this is a spring, and the spring is going to move. Okay, spring is basically the spring constant when distance is moved. Okay, so this is a force. U is force, so we don't consider the force for this formula. Okay, spring constant and the distance is moved. So it's x1. And second spring K2,
X2
x2. Differences. Okay, very simple. When you say why here is x1, there is no other thing because it's grounded. So it's 0. x1 minus 0, that's why we didn't write. But here, when I move, it's x1 as well as x2. Two spring is there. Okay, so it's basically, the formula is delta x. I can see on it. Okay, so that is called delta x. Delta x is nothing but x1, x2. I mean two distance. If one is grounded, then you can take it as 0 actually. But if it's not grounded, you need to put in the respective number on it. Here, second string, there's two x1. I mean x1 and x2. Okay, so you can write the value of it. Then yeah, the x1 minus x2. How about string 3?
X2
X2, because it is grounded. So you don't have the other terms, that was just take x2. Okay, so it has to be the bracket. Okay. Okay, the next one I would like to talk about like damper. This one. Damper is damping coefficient. Whether it's a C or B or A, it doesn't matter, follow the picture. Because it can be anything. I just follow whatever alphabet is given over on that question. So it's B and what is that? X. X. Dot. Okay. Dot. Okay. Because it is here x1 and x2, and it is a coefficient on it, so it's now dot. On it. Then the mass M1, right? M1,
M2
M2. What's that? X1 double dot. Okay, so it's obviously this mass, this X,
Mass
this
is the
double dot. Okay, and M2.
毕业的东西是一个档，你只记得这个东西，
X2, right?
你就6分啊。
That mass. So it's you need to see where the mass located. You can look the distance. So yeah, you are trying to push. It's like a car or even a train. You're trying to apply force. There's a one pass, a second pass, all going to push one side. So it is until to the end. Okay, first step, of course, we return as per it and convert the dot or double dot accordingly. Okay, so sometimes it doesn't require anything, so anyway, right? So to avoid mistakes, I can say. Okay? Okay, here. M1, D square double dot, same.
什么？
2,
我暂且走掉，
D square,
我们不想啊，
2,
我2个都是 credit 的，
D.
才能分到。
Okay, that's great. So once you write,
FE 是
we try to convert as a D,
我的做完，
rewrite even though it's something is not needed, but make it.
那你做对了。
Okay, so that's all. So overall, we have 6 components and we write the 6 components of it. So that is your
FE 我做完，
list out all
只
the
是
system
到我
equations.
调那个，
So we good?
直接调的。
Any questions? Okay, maybe this is a component one. How about force
直接讲。
equation? Where apply force? U.
Angle is not over.
U is your applied force opposite by what? That's all. Because it's equilibrium. So once you apply force here, of course this is against, and this too. That's all. Because it's already considered one system. Okay, so it is of course this applied force, this 4 component 1, 2, 3, 4 is against of that applied force. Okay, so we can turn up here. Okay, yeah, go ahead. U equal to, you can just use the same thing. Yeah. Okay, what? M1, okay. K2. Okay, 2. Okay, so that is your seventh equation. Okay, so you write down that seventh equation. So always need to see when with multiple levels, try to cut it. Then we know what is the separation. So once I separate it, even you can see there is a arrow mark. Okay, and that is indicating you can be able to separate it. Then I can say this versus this. Okay, I mean like whatever force you are getting from these two, opposite by this. So it's like a opposite. Okay, so last one more equation. It's based on a component only. K2, right? And what's B? Okay. Equal to M2 plus K3. Okay, that's all. So you can say this force equilibrium with this one. Okay, I'm trying to push this one and this is going to be opposite to that. So you see where it gets equilibrium. So because now it is based on this force, some reactive force on it, but still consider if I'm pushing and that's grounded over there, so it's acting against the resistance. Okay. So for this question, yes, we have 8. That's all. The part A completed. Okay. So we good? Okay, so the details step, like from there we can say what is the transfer function? Formula. X2? U. Okay. So you can use, okay, now what we can say, we have all the 6 formulas. Try to use these 2 force equation formulas, substitute all the values from there into here. Okay, these 2 you can able to substitute, rearrange and take from whatever values to over here or from here to here, doesn't matter. I want to get it end of the day to this. Okay, as long as you get it, then we get that's all. Very easy. Yeah, it is expansion. Don't use the short note, use a long note. Like this long note. Or you get an A4 paper also, okay, can. Okay? And try to put it all the papers, then you see they can refer, then keep right. Okay? That's how it works actually. Otherwise, more papers will come in. I mean, still can use it. More pages will, until you keep on flipping. Yeah, also possible you get a A1 paper. Then start to write everything. Possible. Okay. Yeah, any other good ideas? Okay, so yeah, apart from explaining, any questions? Component. First thing I want to make clear, everyone, refer the formula sheet, write the equation. That is the first step. Which one? There's no way verify over this. If I write wrongly over here, yeah, of course it's wrong actually.
But the final answer.
Of course, even this step is wrong means that the final answer will be wrong. Okay, so I put it this way. Don't worry about your final answer. Usually I have practiced to take only 1 or 2 marks for your final answer. What I'm looking, whether you procedure or process step by step. That is the most important I was looking. Because sometimes even when I write in some M, I put in B kind of thing, so that's normal. Or when you write in some, you write wrongly. Okay, but what I was looking, procedure, steps you are carrying on, that is secure. Because to be honest, it takes a lot of steps, a lot of long equations, probably higher chance of writing mistakes. If the procedure is right, but maybe the final answer will not be there. Okay. Okay. The best way to do this one, you just follow whatever question from start to end. First, start to write it, then read it. Okay, every step you understand, then close it, then you do it again. Then wherever you get stuck, open and see, then close it, then continue. Okay, so I don't think the second attempt itself you can able to fully complete. Okay, so you start with first degree, then go on higher degree. Okay, first degree we just solved today the water transfer system. Okay, start with a simple one, then go with the complex one. As I told, I am going to upload this tutorial exercise. So this one, it covers topic 1, 2, 3, which is until to your midterm, until next week, whatever you're going to attend. Okay, so you have a few exercises. There's a question and the steps. Maybe not some is very detailed, but at least you can refer something and you get your final answer. Okay. The second one, there's the equation. You can see the equation, then how it derived. Even if you went to block diagram method, then we have equation 3, and this one we solved. Yeah, we went block diagram and this, and we have another one, and we have another system, another equation. Then we have a block reduction techniques, and that is one of the questions. Now this is a set of examples. We have an equation 1 to 6, and then you are formatting. Then you can complete it. Okay, so you have the answer for it, and that is about our block reduction techniques until to get to all the steps. And this is about topic 3. We are heading towards topic 3 only, and topic 3 is relatively easy. Okay, and because it's a direct formula to substitute. Okay, it's not like you got an equation then continually following up. So at least you get some relax from these things. Okay, topic 3 is formula, like a mathematical simple, just substitute. That's it. Okay, so we'll go to that actually. Okay, so any question at this moment? I'm trying to express, and then I'm trying to add more videos and more materials. Okay, so yeah, last 30 minutes. Okay, I'm up. More things. Okay, so that is about our topic 3. Before topic 3, I just have a quick one to say. That's our control system response. Okay, so as we know, it's a system response based on input and output. Your control system in the middle to have feedback to get the desired value. Okay, that's what we are seeing everything, and how you are going to get it, how fast you are getting it. So there's a 3 methods. One is called step input, ramp input, or sign input. Simply to say, like step input is basically like on-off switch. The moment I off, immediately cut off the power. Immediately light will be off. That is we call as step input. Okay. Whereas the ramp input gradually moving, gradually slowing, things happening. When you on the fan or off the fan will be slowly getting to stop. Okay, or you even on also from 0 slowly rotate to that speed. So that is kind of linear, gradually increasing to the particular speed. Okay, sine is another way, something like a ramp, but even more smoother. I believe some of the ceiling fan now you have like this sine input way. So it's gradually flowing the air I mean, even the start of the fan is also gradually slowly moving. Okay, that kind of cycle, so it is more smoother. Okay, so in the maybe you go and see in your remote, the kind of 1 divided by f or something. There's a function button is there. So go and take a look on your remote. There's a button with 1 by f. That is actually sine. So it is like not immediately start or immediately stop or gradually. It is like very smooth, like a wind flow, smooth wind flow. Okay, that is latest fans all have it. Okay, so you go and check it out your fan whether have it or not. Don't have. Okay.
Only 1 to 6.
DC fan have it. Anybody have a DC fan?
How I know DC?
Because nowadays is that's how to say like whether DC or not. Yeah. So basically,
What is it?
if I can say the speed is very fast or not. Normal fan you won't get that speed. The DC fan only get to a very high speed. Or you can another way they say like more windy, so then they are selling. I mean marketing like that, advertisement like that. Like more wind you will get it actually. So that is all DC fans. Okay, because DC motor can rotate 5,000 RPM easily, whereas AC maximum speed 3,000 RPM only. Okay, that's why how fast the fan rotate you won't get any weight. Okay, because it is the limitation of the AC power or AC motor. Okay, but DC, most of the ceiling fan now it comes with DC. They don't have any AC anymore because it is market changing. Okay, anybody directly linked with the fans and everything? Anything linked? Maybe next time when you go course or even another location, you can really see there's a pamphlet or catalog. Then they put like high speed, high wind kind of thing. Okay. Over there also you can look on the remote control. Then you can see signing. It's gradually moving. Okay. So apart from application, what we are going to do it, of course there's a formulas for that to follow, because each step input, ramp input or sign input, there's a formula for first order system. First order system of a formula is like this. Even if you say giving an example, something like a number on top with that's a gain constant, this is a time constant with a 1. Okay. So this is very simple in a way, like when the question says step input, we know what is our gain constant as well as time constant, and the h they will provide. Okay, then you just substitute. That's it. It's very simple. Okay, this formula is not need to memorize. Where's the formula? Refer formula page 4 or page 5? Page 5. 5. Okay. After the block reduction page, you can see here. Table 1.4, page 5. That's for formulas. That way you can see. Standard first order system responses, step input, ramp input, side input, whatever these formulas we are going to use. Yes, even you can take the formula sheet with you. Yes, you can bring this. That's why I purposely given, and we also give to our Kaplan exam unit, so they will print it. These 6 pages, 6 pages. Then they will give it to you, so that I mean, whoever forget, at least they can use it. I mean, without the formula sheet, I don't think you can be able to work even the one question. So you can't memorize all the things actually. But last time we do, but now it's like too much already. So just refer and do it is good enough. Okay, so that's the first order. We are starting with the first order, then ending with the second order. Okay, so second order is slightly, I can say, like a particular function and complementary function is going to split. The formulas anyway you can refer on the formula sheet. Okay, and then I believe last quiz or something, damping ratio, settling time, rising time, and all the formulas you can able to see over here. Okay, so go back to here. Where we are. Okay. Okay, so first about the step input, Okay, that's your first example. Okay, what we can see, the question given like this, and we can plot the system response based on step input theta equal to 6. Okay, so basically what we know already, we can better write out. 4 divided by 3s plus 5, right? Of course, we know this is going to be 1, right? So we need to divide your numerator denominator with that number. So it's end up like 4 divided by 5, 3 divided by 5, 5 divided by 5. So this is going to be 0.8, 0.6. Yes, plus 1. Okay, good. So once you get it, what is your k? Which is on the numerator. Okay, and time 6. And the h is from the question 6. Okay, so we have from the transfer function, we know what is your k, t, and h. Use the formula to substitute all the values. That's all. Finish. So you have a h, k, and capital T. 4.8, of course, 0.8 times 6. Okay, so 4.8 and 1 minus et 0.4. No, 6, not a 0.6. Basic calculation mistake. Okay. Okay, this is very simple and I don't make mistake on here. Okay, so just mere substitution only. Okay, so as long as you get this, you write down here, then use the formula sheet. Take from the, because you need to see whether step input or ramp input or sign input. You can take that formula, then put it, substitute all the values. That's it. Quite easy, right?
Just for
Yeah, that's all. So that's what we expected. But not all in the first order. It's going to be second order and everything. We always start with first order and trying to understand, then we go forward. Okay, are we good? Okay, next one. Okay, this one again same thing, but here the equation not given fully. What we can see the parameters. Let's say the a, b values over here. You can substitute a value, b value, capital letter A, b. So all the variables the given value, nothing else actually. It's just a numerical calculation. Once you're done, you may end up like this. Okay, then you can do and make sure that is 1 and you get k, h and t, then you can able to supply. Okay. Okay, so here same number. Okay, same number, but you can see it's a ramp input. Okay, so we have like three values. The formula is different because it's ramp input. Then use the respective formulas and substitute, and you get the equation.
So the small t, just t unit.
Sorry, unit.
The t, small t.
Oh, t is open. Okay, good question. If they given t equal to 10, then once you get this one, substitute the small t equal to 10, then you get a numerical value. But so far we never ask. So we don't make it so complicated. As long as you get the expression, just leave it over there. Okay. So you know where to refer the formula sheet and read the question, then done. Okay, sign input. Okay, sign input is slightly different. Therefore, you can say sinusoidal or something, or you can very simply to say sign over there on the equation. So when you say sign, it's already known it is a sinusoidal wave. And what is that h value? H is the friend, what we see that is h, and this is omega. Okay, so omega value. Then you know already k and t, so you have it. So that's how we derive the 4 values on it from the transfer function. Question on this. So it's h, omega, k and t from the transfer function. So once you get it, yes, the formula is very big. Okay, so just substitute onto the formula. Okay, so this is wait, there's one extra thing on here. Okay, because on this equation, yes, you have all the numbers h, omega, k and t. So when you say k, h, yes, we have omega, t also have it. Sinusoidal omega, small t, you don't need to worry, just leave it as small t. But this one, pi, is not there. Okay, so we'll come back on this. K, h, omega t and omega t square and minus t. So only this one you don't have. Okay, the pi need to calculate. How to calculate? So once you substitute all the other 4 values onto the equation, substitute over here, you will get like this. Okay, then you can substitute this theta as a 0. Okay, so when this value is 0, then you can rearrange the equation, then we can solve it actually. Or in another terms, like theta, the t value is 0. Okay, time. You better write down so that it will be easy to follow up, because this is consider our last today. So get more energy. That's the last question. Okay, so maybe I'll start from here. At least from this step to this step is mere substitution of all the 4 values. From here, I'm moving towards here. This steps I'm trying to explain. So for that is basically the time, initial condition, small t equal to 0. Okay, then substitute onto that. So basically the theta is 0. You better write down 1.597 sine 0.1 t minus y plus 0.095 exponential of minus pi by 3 t. E of the difference. Okay. Let me reconfirm sine. Yeah. So everything is there. First I write the equation. And initial condition, this is going to be 0. And whenever you get t value, you try to make it 0. So 1.597 sine. When this is going to be 0, this entire term is going to be 0. And what do you get? This following. Right? Then here, exponential, anything to the thing? 1, okay. 0.095. If this is 0, everything exponential is 0 is 1. You can check on your calculator. Okay? So it's going to be 1 on it. Then this term you can rearrange, then you can work on it. In a way like, first I move, not minus, okay. Minus 0.095, 1.597 sine pi. Then I can say, is it coming? 1.597 sine pi.
minus 5.
Minus 5. Oh, this one, yeah, okay. So it's going to be cancelled later. Because sine it automatically come, it will be cancelled. Okay, so any question? So once you put 0, you become 1 here and here it become 0 on it. then rearranging so that you will get like a ratio, and here maybe get a number so easier to work out. What is the value of this?
奔3个小时，分就你奔你这么回家，不要我奔，发现谁更好了？奔要8点，example 我们拿一个 book，
What is the number?
我们拿5片8点奔，就是你们奔，把那个5片转来。
0.0 no, without sign inverse. Just 5 595. Correct? Okay. Then sine minus of this. Right? Take a sine inverse of this. In your calculator, we have a sine inverse function equal to minus of this. So use your calculator, sine minus of this. I believe the answer will get minus something. Then this minus and that minus will be cancelled. Sine inverse, you know how to make it? Even in your phone, you can make it land space. Then you can use your phone to be a calculator. Okay. Otherwise, you can download the phone scientific calculator in your search on the Play Store. You can able to see. You can able to install. You don't need to buy a separate scientific calculator. Your phone can be a scientific calculator.
Exam cannot bring phone.
Of course, exam. You don't expect because you can do anything over on the exam, so it's not possible. What's the answer? This one? Negative 0 point?
Oh, we got billing.
Oh, 599. Okay. That minus will be cancelled. So it end up like 0.0599. Of course, the same thing. Over there, only 2 lines. We write a very long line to write actually. But it is the same thing. So we say like over here, substitute 0. They are written over here. Then rearranging, finally get the answer. Okay, the next step. Of course, this is the one. We are rewriting here just with this value, nothing else. Pi value we are going to put and rewriting. So this and this is the same thing. It's only we have a pi value. Okay. Okay. So question. Your assignment have this one. Yes, mid semester. Next week. So, any question?
So will be first order or
This is first order. Yes, this is first order. It is open tomorrow.
time,
Yeah.
right?
Yeah, it is. Yeah, it
2
is
hours.
trying to open a particular
hours.
timing. Let me check it out the timing.
2 hours.
2 hours.
Only.
It's going to open.
2 hours. You start, you do.
8 June finish.
Shit.
Yeah. Not available until 9th. Okay, let you finish your quiz, then it is opening. I mean, not really. Sunday morning opening. But your quiz is Sunday night is finished. Yeah, so you have like a 17th. 17th, I believe, is next week. Oh, even Monday.
要2个小时要这
Yeah.
样做。
So you have more than a week.
Walao.
So what do you think? 2 hours is not enough.
No, 1 week enough.
1 week enough. Because the thing is, everyone has the same answer. I mean, sorry, same question.
Oh,
Oh. I mean,
So one more.
yeah, it is the same, I think.
but same question.
So it cannot be the same answer.
Yeah.
We should have, because all have the same thing.
Oh,
I don't think, let me see, because need to do it.
hey,
People are so clever.
why you?
Good, now I can do it. Let me see, because I also forgot to ask you how it looks like. Oh yeah, You okay? Out of 4 questions, 2 questions is same. 2 question is changing and from the bank.
The number.
No.
Yeah, even the question. Yeah.
So everyone we get different.
Every time even login also different. Okay, maybe I do one thing.
But there's only one time login. No multiple.
Once you start, yes, one time. But you can go until to that page. Let me.
So question one is answer function.
Okay, that is yes. We have like a linear system, like just now what we did, like this, and like this, system equation thing. Okay, so that is your question will be. Let me see.
So like this just now blocks.
You can be open. It is equation method or block diagram method is your preference. Then second one, reduction block techniques. That is your second question. Third is also reduction. Fourth will be this question.
很乖嘛。
This
有
question.
人個答案。
Step input, ramp input, sign input. Okay, so that is your third. I mean last one.
Which order?
So it is always in that order.
No, I mean second order, first order.
Okay, we try to see first order. Okay.
Question
I mean depends with the question bank. I will recheck anyway the question bank. Okay, so maybe I will put it this way. Since the time, as we say, like 1:35, more like 2 hours, 15 minutes. Usually 2 hours. We plan like every question like 30 minutes. So 15 minutes is for uploading. That's why it's like 1:35 actually. 2 hours, 15 minutes.
he needs to upload can
Okay, I ask again, never mind, I ask
You already have an answer. Maybe I'll put it this way. Make it simple. I'm quite flexible. How long you need? 4 questions. 3 hours. Okay.
One day.
Raise your hands. So 3 hours is okay. Don't change later, because
One day, one
you,
day, one day.
you can do it
One
now.
day, 24 hours.
Otherwise, oh my god. It's only explained in 1 week. What next year? Cannot be. Oh, in meaningful. 4 questions. Okay. Anybody tried? Anybody? Okay, sure. You should not ask that kind of question. Okay.
They try first, someone, please.
Even when you write itself, how long it takes? Maybe consider 1 hour, 1 question. Okay. 4 hours. Okay. Maybe I'll write it now.
Then
4 hours. Then
upload
15
2
minutes
hours.
is for your uploading.
Then later I message you.
Upload is.
Oh, then don't send me.
Sir, I cannot upload, sir.
I mean, this doesn't mean like you are can more things.
Then we upload in wrong place. Upload in the WhatsApp group.
Okay. 4 hours means 240. 240 plus 15. 255. I don't know whether you can get it. Yeah. So anonymously, everyone accept? Okay. Later don't send a man.
round up so 300.
Round hour, 300, sir.
Yeah. Too much already. Okay. The thing is, don't start it until you are ready. Okay. And even if you ask me, next week, Saturday or Sunday, we'll do it. Okay. Whole 1 week, you can do it, practice. And I will give a tutorial exercise. Please refer that and make sure. I will put it into the Google Drive. This one. Okay. Try to keep it, even print it and keep it when you do your assignments. Okay. And maybe if you want really practice.